today we are presenting the next evolution step of Etherisc. And to gauge your expectations, I'm not going to talk about our large projects in Africa with the Lemonade Coalition. That all has been covered by the other talks. I'm going to present our next evolution step, which is staking. And so this becomes a bit technical, maybe, for one or the other, but feel free to ask questions afterward. And so let's dive right into the matter. So where do we come from? We have built Etherisc based on the DIP token, which has been launched in 2018. Then 6 months later, we released the first release of the GIF, the Generic Insurance Framework. GIF is something like an operating system for insurance products, something like a Linux for insurance. And so it provides the basic building blocks and functionalities to run an insurance product. And on this GIF, we created also a new legal model, which is specific for Germany, but also has some implications for other countries, which allows us to operate insurance-like products with a much reduced level of regulation, basically, and which has been approved by the German regulator. And then, in the consequence, we have also launched our first products based on the GIF in Africa, Acre Africa, with 17K farmers last year, and the next seasons are currently in production. We have joined the Lemonade Crypto Climate Coalition, and last step, we are currently building also a developer sandbox where everybody in 5 minutes can launch its own instance of the GIF, experiment, develop products. And so what is missing? Missing is one important step in the architecture. You see here, this is the general layout of the GIF. We have a basic layer at the bottom, which controls the policy flow, the life cycle of an insurance. And on the top, there are individual building blocks which can be provided by any party, like product owners, Oracle owners, and risk pool keepers. So we already have the first two, the product owners and the Oracle owners, for flight delay, for crop insurance, but we are still lacking the third pillar of the generic framework, which is risk pools, and which can also be run by anybody. And this is also maybe a bit of difference, for example, to the Nexus Mutual model, where they have only one big capital pool, which serves for everybody. And we are going a bit more unopinionated approach, where actually anybody can launch such a risk pool. But this is still in development, and so I'm very proud to present today this next step, the staking model for Etherisc and how it works. And to understand how it works and why it's important for us, staking is, of course, a very common term in blockchain. But to understand how it works, let us first have a look at our revenue model. And this is also, with Etherisc, everything is generic. Yeah? So this is a model which can be used in any product, with any country, with any jurisdiction. It's always the same because it's a basic model of any insurance, essentially. Yeah? Even, I think, in a certain sense, even other projects like Nexus or whoever is basically operating a similar model. Yeah? But let's explain what we are doing here. We have the insured on the left side. He's paying a premium. Part of the premium is simple cost, covering the operating cost and distribution cost, whatever. These are, in our case, we call them sovereign workers, because everybody can engage in this role. Anybody can be a distributor, can be a product developer, can be an actuarial, can be a license provider, whatever. And of course, these people get paid with a certain amount of fee, and the rest is of the premium is then put into a risk pool. And today we will explore how the internal structure of these risk pools look like. And the risk pool is funded by investors who, obviously, they are not doing this all for altruistic reasons or just to lose money, but of course they expect to earn money. And they earn money by providing capital and receiving also a revenue for locking their capital for a certain period of time. So that is essentially the model. But now let's have a closer look on the risk pool itself, how it works internally. Yeah, this is what we already have. We have already, with AK Africa, with our other project, Flight Delay, we have this gray area. So this is already working, and we are soon covering this yellow area with the risk pools. Okay, and of course, very fundamental for the Etherisc platform, all of this is always connected with the utility of the DIP token. What is the utility of the DIP token? Basically, we can name 3 aspects. The first aspect is staking for services. So everybody who wants to earn money on the platform by providing services needs to stake a certain amount of DIP tokens in our platform as a membership fee, you could say. Yeah? So to be able to earn money, you need to have some DIP tokens. Second layer is the governance. This is also for the future, but this will be an important part because every instance of the GIF on whatever platform, be it Avalanche, be it Ethereum mainnet, be it Gnosis chain, every instance is operated by a DAO. And the DAO will have rights to decide, for example, which products can be launched on this specific instance. Yeah? So, for example, if there is already a flight delay insurance, then the DAO could decide that we would not like to have a second competitive insurance of the same type on the same instance. But of course, you could also launch a different instance and launch your own product. So it's not really restrictive, but it's just people who run an instance of the GIF, they should have something to say what's happening on their platform. And most important, the top layer, staking for risk pools, where you actually put your DIP tokens in a risk pool together, maybe with some other assets, stable coins, whatever. But the DIP token will be always an essential part of the risk pool just to make sure that only those people who have actually paid for the development of the whole platform will also be the people who in the end will profit from this investment. And therefore we need to link the usage of the platform to the DIP token via staking. Okay, before we start, let's just have a short look on how a typical insurance premium is structured. Yeah? If you pay a premium for an insurance product, of course you hope that all of your premium will be used to pay out your losses, yeah, in case of a claim. But it is not the case, because insurance is a complex business. You need a lot of people. People need to be paid. They need to get salaries. And you need to distribute the product. This is all cost. This is the yellow part. Then, after you have subtracted the pure operational cost and distribution cost from the premium, you will pay some capital cost for people who provide capital in the risk pool, premium for locking their capital in this pool. And this is the blue part, capital cost for expected loss. And the remaining part of the premium is only used to pay out the claims. Yeah? They are first pooled in the risk pool, but then they are used, and in the average, all claims are paid from this expected loss. And unexpected loss is covered by the reinsurance premium, so the reinsurance will cover excessive losses in case of catastrophic events or something. Therefore, you pay a reinsurance premium. That can also be solved via our risk pools, but that is a different story. Let's first assume that we just have the reinsurance stuff covered. Okay, how does a policy work? A policy works like this. You have a blue timeline, so this is the life cycle of a policy, and in the beginning you pay a premium, $100. And of course, immediately you will subtract some cost from these premium to pay the distribution for whatever reason, operations, whatever. Very simplified here. Of course, the costs can also be distributed over time, but let us keep things simple. Costs are $20. Okay, what can happen? In the best case, nothing happens. Yeah, there is no loss, and what happens? The rest of the premium is the profit of the insurance company, or in our case, the risk pool keeper, because of course we have no direct insurance company. Maybe there is a legal entity behind it, but the model itself is generic and does not assume that there is a specific company behind it. This is a positive case. Yeah? No loss, and the full remaining premium is profit for the people providing the capital. The other case is, of course, negative. You pay a premium, cost the same, but then at some time you have a loss, and the loss is, of course, large in comparison to the premium, and you end up with a loss. Fortunately, in the average over many policies, the overall product should, of course, be profitable. Yeah? So we can express this like this. You have a premium, you have cost, and you have an expected loss. So this is the average loss over many policies. And in the average, the expected loss is, for example, $60, and you have still a profit of $20. And so that is like every insurance works like this, basically. And we will need these small images in the next slides. So let's say we have now a certain insurance product. Now we have a lot of policies, and now we pool all these policies together, and you see these little icons. These green squares are representing a single policy with its cash flow, premium, income, profit, whatever, and now more policies coming in. There is a loss. Okay, it's covered because we have many others. Then another bunch of policies coming in. We have more profits again, more profits. Again, a loss, but it's still covered. So the whole pool still stays in the green, and it's still profitable. Yeah. So that is a positive case. Of course, we also need to look at the other way around. So let's say we have something like a catastrophic event. We have still policies, but even in the first bunch, we have some losses, more losses, still more losses, and eventually, okay, now the whole pool turns red, and probably we now have a phone call with a reinsurance company which will cover this excessive loss. So this is, of course, cannot be excluded. Typically, if the pool is large enough, then it should not happen, because you will have enough profitable policies which will cover the losses. So this is just the background for our model. And now we look into how we represent this model for Etherisc. We have these risk pools, and now we have one crucial step. And the crucial step is that we bundle specific policies, which are, again, these gray boxes. A gray box here, the small gray box, is basically a policy where we do not yet know that it will be profitable or will have a loss. So it's just at the beginning. Yeah? People have paid their premium, nothing has happened until now. So we bundle these policies into certain bags, and each bag is represented by an NFT. NFT is a non-fungible token, a very versatile instrument on blockchain, where you can actually link a specific asset, you can link a specific data set, you can link a certain set of policies to one specific token, and this token is represented by a standard, and the standard makes it very easy to handle this. Yeah, there are libraries, software, smart contracts, which make it very easy to deal with these NFTs, and all of you know these Bored Apes and these little JPEGs which you can use for your Twitter profile picture and so on. So these NFTs typically are static. Yeah? So once minted or created, they are fixed. They never change anymore. But there is also a different type of NFT which can change its content during its life cycle. And this is what we need here, because an NFT, for example, for flight delay, would be an open NFT, which would take all the policies which come in over a certain period of time and would digest them and bundle them. And we do not know in advance how many policies are bundled in this first NFT. These NFTs can be bundled by various criteria, either by time, all policies which come in 2022, all policies which are covering flights from Europe, all policies which are covering flights in Latin America, all policies which are covering Lufthansa flights, whatever. Yeah? So there are many different types how you can bundle these NFTs, and it's completely open. It's up to you as a product designer or risk pool designer to create the criteria for these NFTs. Now, you bundle these NFTs, and now you can link this NFT with a certain capacity. A capacity is basically a specific number of assets or collateral which covers the losses of these specific NFTs. And in this case, for example, we have 100K for the first NFT, $200,000 for the second, 400,000 for the third, and 400 for the fourth. And each of these pools or each of these NFTs has a specific capacity, which is defined by people who create these NFTs. And of course, after we have provided this capacity, we can then start selling policies, because every policy needs an existing collateral that you are able to sell it. You cannot sell a policy if you have no money in your bag. So first, create the NFT, provide it with capital, then you can sell policies, bundle them in the NFTs, and so you have now these bags of NFTs, and you can see there are also overlapping NFTs. So this policy in the middle is covered by two different NFTs. Both provide capacity proportion to the capital locked. For example, in this case, the NFT number 2 provides 200 and the NFT number 3 provides 400K. So one is 1/3 and the second is 2/3 of the capacity of the risk. And also the profits and losses are distributed according to the ratio of these NFTs. So that makes it also very flexible. You can cover a policy by multiple NFTs. Okay, so this NFT now has a specific value because you can calculate it. You have, of course, the assets which are in the NFT as a collateral, and then you have the actual happened losses and profits and the calculated profits. Some policies have already expired, you have a profit. Some policies have a claim, they have created a loss, and some policies are still running. They have an expected profit, and this can be calculated based on standard insurance mathematical models, and so an NFT always have a specific value. So it's a financial asset, and you can sell it, you can buy it, you can trade it, and that makes it very flexible. But you have a problem. These NFTs are very specific. They have a specific number of policies into it, and so it will be not easy to find a buyer for these NFTs or somebody who will provide capital, except you have a very specified investor who exactly wants to have these type of policies. Or, for example, my standard example is maybe you have insurance for oil platforms. You have 10 oil platforms worldwide which are covered by the risk pool, and then you have an investor who says, I want only these 3 oil platforms to be in my NFT, and I will provide cover for exactly these 3 policies. That is possible, but probably it's not the usual case. The typical investor wants something which is tradable, which is fungible, which is can be put on an exchange. And so we need another step. We have first, of course, we have this primary risk pool with the NFTs. And then we need to make these NFTs fungible. And this is also a standard technique on blockchain. If you have a bunch of NFTs, you call it fractionalize them. You can put them again in a bag, and then you can sell the bag or pieces of the bag via standard ERC20 tokens. And this is what happens. So we put these NFTs in a secondary risk pool. Now we have these NFTs in one secondary pool, and this pool cannot now be sold to investors. The investor puts in the money, DIP tokens and stable coins or whatever assets he likes, but in any case he will put in DIP tokens. Then he will receive fungible risk pool tokens. These are standard ERC20 tokens which can be traded on Uniswap or any decentralized exchange. And then this collateral will be routed forward to the primary risk pool and provides the collateral for the policies. So by this trick we have fungible risk pool tokens which represent a specific set of NFTs which have been created from insurance policies. And this model is very flexible. It can cover any type of structure, any type of policy. Of course, we can also have a very simple system where all policies are one NFT. We can build this model as we want. in reality, it will work from the temporal development, it will work the other way around. First, you have the investor. The investor provides capital. He receives the RAP, the risk pool tokens as a tradable token. Then we put the collateral in the primary risk pool. We create the NFTs and put the NFTs in the secondary risk pool. Yeah, that is the sequence, how it will happen in reality, because you need to do it the right way. Yeah, so first provide the capital, then invest the capital in the primary risk pool, create the NFTs, and everything is fine. But that is just a matter of how the sequence is. Okay, now that is not the end of the story. Now you can combine different secondary pools with different primary pools. Yeah, so you can cover one primary pool with one secondary pool. You can cover two primary pools with one secondary pool. You can cover one primary pool with two secondary pools, whatever you like. Yeah, so it's an open, it's a generic framework as always. So you can build any structure you like. You can, for example, you could build something like the syndicate, what Hugo mentioned, yeah, the syndicate system, where you have syndicates, people, experts who invest in specific risks. Everything can be done with this model. And so I think we were also asked what is the difference between Nexus and Etherisc. And to put it in simple words, I would say Nexus is very opinionated on how they do things, and I think obviously they do a great job how they do it, but they're very opinionated. They have one risk pool and one capital, and everything is built on top. We are not so opinionated. We are very generic. You can choose what type of structure you like and what fits best to your purpose. So we are not that opinionated, and I think that makes a bit of the difference. And of course, both can be combined. Yeah, you can, of course, also link a Nexus pool with, for example, some intermediary layer to a secondary risk pool on our side, or you can integrate reinsurance by Nexus with our products, and so on. So no limits to your fantasy. This is the nice thing of blockchain, that things can be composed. Yeah, composability is one of the big assets of blockchain in general. Okay, come back to the original model. We have the existing part. We have now seen how staking works and how we implement the tokenized risk pools. And of course, how the utility of the DIP tokens works in this context. And yeah, that's all for today. I'm open for your questions. Thank you for your attention. Yeah?
Why do you have to use NFTs? Because, I mean, other cryptocurrencies in general already has like some assurance for the flows to happen because it's a community. So, like, could you please explain why?
So the question for our online audience, the question was, why do we need this specific layer of NFTs? Why can we not just simply use fungible token? Of course, we have also explored this, but we found out that we need this layer because we do not know in advance how the structure of the risk pool will look like. Yeah? Policies come in, they are sold, more or less. Policies can have very specific features or properties. So an NFT is the ideal instrument to cover this complexity of the risk pool. And then we go the second step and we fractionalize these NFTs in simple tradable risk pool tokens, which can then be, as any RSC20 token, can be traded on an exchange. More questions? This is not the case, then thank you so much, and I can hand over to my dear colleague. Where is he?
Christoph, one more question.
Yeah?
Typically, what type of investors will be the ones that Etherisc will be reaching out? The investors, what type of investors are the ones that Etherisc will be reaching out to buy the NFTs?
Yeah, that's, it depends on the type of policies and the volume what we are talking about. Yeah, for example, if you are insuring an oil platform, you probably have policies which need a lot of capacity in the millions, and probably you need very specific investors who are able to provide that capital. But if you have, for example, our flight delay, yeah, where we have for example, all flights from Lufthansa, all flights from KLM, maybe this specific NFT, which you could create for the specific subset of flights, would be cheap enough for a normal guy to put some $100 or $1,000 into such an NFT. Yeah, that would be possible, specifically if there are others who are adding capacity, because you have seen the NFTs can overlap. Yeah, so many people together can provide capacity for the same policy by just sharing the same risk.
I'm trying to understand the concept. So can an NFT be negative, or is it not possible because of the risk pool before?
So the NFT has, of course, a collateral, and the collateral can go to zero, yeah, in the extreme case of a catastrophic event. If the product is structured in a way that we have, for example, reinsurance, then the reinsurance would then jump in. The NFT would not go below zero. It cannot go below zero, because then the reinsurance would cover the rest of the losses.
Okay, makes sense.
Yeah?